Hello there, friends. Today we're going to be solving problems 1A, C, and E from section 2-3 from the book Number Theory by George E. Andrews. And the problems deal with the Diophantine equation. I'll keep this up here. Diophantine equation. So, let's get started. Problem 1, 1A, goes as follows. So, we're being asked to find the general solution if a solution exists of these equations. So this is 1A. And so the way you go about this first is you find the greatest common denominator between these two values. GCD of 2 and 3. Since they're both prime, their greatest common denominator is 1. And you check whether this GCD divides this value. In which case 1 clearly divides 1. 1 clearly divides 4, I mean. And so now we have to find a solution, an ordered pair of x and y that solves this value. And since the values are pretty small, you can kind of find one out. One pair that I found, pretty simple, was just -1 and 2. You could just substitute these values in. At -1, this is just -2, plus 3 times 2 is 6, which is just (-2 plus 6, which is 4. And the solutions are of this form, the general solutions. X naught plus b over d. Here d refers to the greatest common denominator, and b refers to the initial value here of y, and y is y naught minus a over d. Again, the a refers to the initial value of the x position here, and d refers to the greatest common denominator. So the solution of this problem, the general solution, is x is equal to x naught, which is -1, plus 3t. I forgot to write the t in the general solution over there, and then for y it's 2 minus 2t. There you go. Now on to problem 3. On to the second problem, 1C. 1C is as follows. We have 15x plus 51y is equal to 41. Now, unless you're quick with your division, it's not clearly apparent whether or not these have some kind of greatest common divisor of 51 and 15. So 15 is 3 times 5, or 1 times 15. And clearly this isn't divisible by 5 or 1. And you can do 15 fairly quickly. 15, 30, 45, 60. So is it divisible by 3? Now, most of you might know this, but if you don't, there's a nifty little trick that you can do for figuring out whether something's divisible by 3 fairly quickly. And what you do is you can actually just take the sum of the individual terms, and it'll tell you fast whether it's divisible by 3 if the sum of the terms are a multiple of 3. So 15 is 1 plus 5, which is 6, so it's divisible by 3. 51 is 5 and 1, which is 6, which is divisible by 3, so 51 is divisible by 3. Now it's a small number, so you could have just divided by 3, but it's one of those nifty little tricks that you can just keep in the back of your pocket So the greatest common denominator is 3. Now, does 3 divide 41? And as you can see, 4, 1, 5, 5 isn't. So 3 does not divide 41, in which case there is no solution. No solution to this problem because it did not meet the conditions needed to have one. Now on to our last problem, problem 1e. And 1e goes as follows. We have 10x minus 8y is equal to 42. And so we can see here the greatest common denominator is equal to 2. I should write this in proper. Of 10 and 8 is equal to 2. 2 does divide 42, and so now we try to find a solution. Since this is all divisible by 2, you can actually just divide by 2 now, or save that for the general solution. I'm just going to do it now because it saves me some work. So we have 5x minus 4y is equal to 21. And so again, this is another fairly simple one. We can say x is equal to 25. Y, in this case, is just 1. That's 25. Oh, sorry. Is equal to 5. So 5 times 5 is 25. Minus 4 times 1, which is just 4. Which is 21, which is the value we wanted. And so the ordered pair is 5 and 1. Let's write down the general solution. And so the general solution is of the form x is equal to 5. Since the initial value is minus 4, or if you didn't divide, it would still be 5, probably, actually. The solution might be a little, if you kept it in this form, the ordered pairs would still be the same, actually, 5 and 1. The only difference is you would get an 8 here divided by 2, and you would end up with the same solution as shown. And the general solution for y is the initial, so 1 minus the ordered pair over here, which is just 5, 5t. That's your solution for 1e. So there you go. Now if you have any questions or you need something clarified, feel free to let me know in the comments section. If there's something else you would like me to solve, say from a different textbook, worksheet, homework, or just something you're interested in, feel free to let me know about in the comments section as well. Thank you for watching, and I hope you have a nice day.